Hello, everyone, and welcome to our Smart Industry live stream today. The title of our program is Tech Tips for Future Proofing Legacy Equipment with Condition Monitoring. Our SI program today is brought to you by Advanced Technology Services, who are our sponsor. As the industry continues to undergo rapid technological transformation, manufacturers recognize they must evolve their processes, systems, and data to stay competitive. Older legacy systems pose a threat to digital transformation, and despite manufacturers recognizing the limitations of these outdated and disconnected data sources, 74% of manufacturing companies still rely heavily on legacy equipment. Joining us today to present the advantages of condition monitoring on legacy equipment and how sensor technology enables industry to make data-informed decisions is Sean Lowery, who is the Customer Success Manager at ATS. Sean is a certified reliability leader with nearly 2 decades of experience driving asset reliability and implementing predictive maintenance programs across various industries. And we welcome Sean.
Thank you, Scott. Pleasure to be here to discuss this with you guys and everyone else. In my 20 years of reliability experience, I've seen kind of firsthand the impact and the positive impact of proactive maintenance strategies and what it can have on not only your normal modern technology and equipment, but also legacy equipment. Today, I'm going to be sharing some insight into that real world application of condition-based monitoring and how we've seen it extend legacy equipment life on top of other operational benefits.
Thank you, Sean. We have an expert on condition monitoring in the house. Definitely. We have some questions to guide our conversation today. First off, why is condition monitoring crucial for legacy equipment, and what can it prove on ROI?
Yeah, so first of all, legacy equipment is oftentimes hard to find replacement parts and to service some of that older equipment. It can also have very long lead times to get those replacement parts in. So by utilizing CBM methods to detect and find any defects across those assets well in advance of failure, it can help with the planning and scheduling to get those replacement parts in ample time before failure. But it also can extend the life of these assets to where you're not having to replace those parts as often. Secondly, going into the ROI, when using condition-based monitoring for ROI, it kind of just extends from that previous statement I just made. You gain that ROI by not having to experience that downtime unexpectedly or having your assets fail unexpectedly and having to use that time to go try to find these parts. And I've even seen it to where a failure happens and they've got everything ready, but they have to stay shut down because they're waiting another week to get their part in. So that's really where you're going to find your ROI is that unscheduled downtime and getting those legacy parts in enough time to where you can make that repair quickly.
Great stuff, sir. Great stuff, Sean. Another question for you. Can you explain the technology and benefits of using temperature and vibration sensors specifically for legacy equipment?
Yeah, absolutely. So vibration analysis has been around for decades now, and with everything else, it has evolved over the years. And the technology works simply by just taking a sensor to measure the vibrations of equipment. Those vibrations come out and they're represented to an analyst in the form of a spectrum or a time waveform. And from those graphs and those plots, skilled analysts can extract that useful information that is particular to the equipment from which that data is collected. So temperature and vibration are often the most utilized tools for monitoring not only legacy equipment, but also other equipment around many industrial spaces. And this is mostly due to the ability of that vibration technology far and wide. It can detect numerous amounts of issues, ranging anywhere from mechanical looseness to structural looseness, to misalignment, bearing wear, bearing defects, imbalanced fans, cavitations of pumps, soft foots. It's just a wide range of issues that the technology can detect. So that's why, in my opinion, it's probably the most widely used technology across the field when talking to condition-based monitoring and predictive maintenance.
More great detail, Sean. Thank you. Our
Mhm.
final question today: how can manufacturers successfully transition from reactive maintenance to proactive predictive maintenance, or PDM, using these sensors on older machinery?
Yeah, so that's a question that that's the golden ticket, and that's why a lot of people might be tuning in today, and they also it's a tough one to solve, but it's solvable. When it comes to transitioning from that reactive state of mind and that reactive maintenance to a more proactive and predictive maintenance, first of all, at a plant level, you're looking at a culture shift. You got to start educating your team at a local level of the technology and the benefits of the technology of sensors and condition-based monitoring, and how you can better utilize that to make their jobs more easier and more effective. Um, you don't have to get extremely technical with a lot of the information, but it's important that everyone at a local site understands that the technology is there to help them and support them and not hinder their efforts or create extra work. It's also important for everyone to be involved from a reliability perspective, and moving into that phase of shifting into proactive. It's really all encompassing. It's not just a mechanic or an electrician or a planner. It's everyone from engineers to managers to plant managers, even all the way up to the corporate levels. And then you need to apply the proper technology to the issues you are facing at your facility and at your site. So, for example, if you have a lot of fans that are failing, we would utilize vibration analysis to monitor those motors and those fan bearings. Uh, that would be an effective strategic deployment of sensors to help jumpstart the program with an existing known issue that you're trying to correct. You can apply the sensor technology to it, take that data, and then you have at least some heads up notification of when something goes wrong or is going wrong. So it's also very important not to over apply sensors at your facility that don't provide useful information or that provides value. So, for example, if you have a piece of equipment and it fails and it does not cause, your production line to stop running product, and or that item fails and you could quickly and cheaply repair it, then it may not be the best use of the application of sensor technology to provide that value and give you the heads up. For example, when it comes down to going from that shift from a reactive to a more proactive state, we've had a customer that was extremely reactive. Every day they were out in the plant trying to fix failed equipment or firefighting, in other words. And we went out, ATS went out and installed these sensors on some of their critical legacy equipment, and we began monitoring. Almost immediately, we started seeing issues that were detected that were coming from the data from our sensors, that we could present to our customers in a way that they could get out and plan and schedule the work, and be more proactive and predictive versus reactive. So in this particular situation, we detected a few motors that needed lubrication. There wasn't major bearing damage or wear on the data, but we did detect that there was a need for lubrication. So in this particular circumstance, we communicated that over to the customer and the site. And then with that advanced notification, they were able to schedule a lube route on their own time, and they were able to perform that lubrication uh, and get those levels back down. That action, which is planned and predictive maintenance, yielded was a result of resulted in the extended life of the equipment and creating that failure mode or reducing that failure mode and the implications of not addressing it. So at the same time, when you're trying to utilize all of this information, data, making data driven decisions is critical. So most all sites have tons of data, but when you're trying to get into that proactive and predictive maintenance state of mind, all decisions are based on the data and what is it telling you. So if you utilize existing data plus data that's being gathered from any kind of PDM program, PDM sensors, then you're more able to identify and plan for issues that can result in failures or unplanned downtimes. So when you get these advanced notifications, then everybody wins. You're not out repairing or replacing an entire $30,000 motor. You're simply taking 15 minutes and you're doing a lubrication on it.
Very good. Great answer, Sean. One question I had was, can you describe proactive maintenance from a route-based and sensor-based solution? Is there a benefit to having both?
Absolutely. There's always a benefit, and the state of mind that I have is there's no one singular answer for best practice, and oftentimes best practice is a combination of several things put together. So proactive, would be maybe some PMs or inspections and identifying problems before they really rear their head. Being proactive with your inspections or with your PM routes and schedules and staying in compliance of those schedules that come out on your CMMS systems. That's proactive. Getting the data from the sensors and having the sensors out there and utilizing the data from those sensors, that in itself can be considered proactive. But what really makes it proactive is the action that the site takes to get in front of those issues.
More great answers on condition monitoring. Thank you, Sean.
Yes, no problem. I'm happy to discuss anytime. And if anyone out there is listening and they're interested in learning more about how ATS can help, please feel free to schedule a demo or a tour of our R360 Tech Center or by visiting our website. So thank you again for having me, Scott. I appreciate you taking the time to talk about this with me.
It was great to have you, Sean. Thank you very much.
You're welcome.
This concludes our Smart Industry live stream with Sean Lowery, Tech Tips for Future-Proofing Legacy Equipment with Condition Monitoring, sponsored also by ATS. This program is available now for on-demand viewing on our various social channels and will be posted to Smart Industry's website shortly. From Smart Industry and our sponsor, Advanced Technology Services, thanks to our audience for joining us today, and have a pleasant remainder of your Thursday.